Here are three brick facades. They look identical. Same color, same brick layout, same joints. Which one is the best? Let me show you what is behind each one. The first is traditional masonry veneer. The second is steel frame with thin brick slips fixed to metal rails. And the third is insulated render system with brick slips bonded to its surface. And here is the interesting thing. Even now, when we have seen what is inside, the answer is still not obvious, because what counts as the best depends entirely on what you are measuring. My name is Eugene Korch. I practice and teach facade engineering, and today we are talking about brick and brick slips. Let us start with the basics. When you have several systems in front of you, how do you actually decide which one is better? You need a framework for evaluation. Without one, the conversation goes nowhere. One person praises reliability, another talks about installation speed, a third focuses on the cost per square meter, and another prioritizes embodied carbon. The first question is always compliance. That means building regulations, fire safety, planning requirements, and client's design brief. If your project has passed all the required regulatory approvals, congratulations. The basic requirements are met and the building works. But that is only the entry ticket. The fact that a chosen system complies with regulations does not, on its own, tell you which option is actually optimal. The second question is money. And this is where it gets interesting. Because money is not just the price per square meter of the system. It is a full combination of factors that determine what the facade actually costs in the end. It is logistics. Can you physically get the materials to site? In central London, for example, there is sometimes simply nowhere to store even a single pallet of bricks. It is programmed. Every single week the building is not finished is a week without rental income, without sales, without return on investment. For a typical residential tower, 1 week of delay costs significantly more than you might expect, and the losses compound fast. It is labor. Try finding skilled bricklayer in 2026. The average age of a UK bricklayer is 52. The construction workforce has shrunk by over 300,000 since 2019. And bricklayers' number are at their lowest since 1998. And suddenly that cheap traditional brickwork does not look so cheap anymore. So what are your actual options when you need a brick facade? Traditional facing brick masonry is the benchmark that everything else is measured against. Full-size brick, 102 millimeters thick, weighing roughly 200 kilograms per square meter, the system is century-proven and looks beautiful when it's done well. A skilled bricklayer lays about 5 to 7 square meters of facing brickwork per day, which works out roughly 1 square meter per hour, and that is in good weather. When it rains or when the temperature drops below 3 degrees, work stops. Mortar needs warmth to cure, and if it freezes before it gains sufficient strength, the bond is permanently compromised. The next option is mechanically fixed brick slips. These are thin brick units, typically 25 to 40 millimeters thick, that clip or lock into the horizontal metal rails fixed back to the rain screen cladding subframe. The weight of these systems is around 60 kilograms per square meter, which is roughly a quarter and sometimes a third of weight of traditional masonry. That weight difference changes everything. Your structural engineer can specify a lighter steel, your foundations become smaller, and your transport costs drop noticeably. Installation speed is 15 to 20 square meters per day, which is 2 to 3 times faster than traditional brickwork. You can work in light rain and at lower temperatures. There is another practical advantage. Brick slips can be installed from mass climbers rather than full scaffolding. It's significantly cheaper and faster to set up. Traditional masonry typically requires full scaffolding. And finally, there are adhesive-fixed brick slips. Thin, lightweight brick slips are simply glued to the substrate. Sounds ideal, doesn't it? Lightweight, simple and cheap. But there's one problem. They fall off. And it does happen. Industry publications and building safety reports have documented cases of adhesive-fixed brick slips detaching from occupied buildings. In several of these cases, bond failures were noted after 8 to 12 years of service. Not immediately, but well within the expected 60 years design life of the building. Why does this happen? Adhesives are excellent materials in themselves, but most of them lose flexibility over time and become brittle. At the same time, brick slips are porous. Water gets in through the face and through the joints, accumulates behind the slips, and then winter arrives. The water freezes, ice expands by about 9%, and the adhesive bond starts to crack. Repeat that cycle 100 times over a few winters, and something will eventually give. Add thermal movement on top of that, the facade heats up in summer sun and drops below zero in winter, and sooner or later something comes away. Now, to be fair, modern adhesives are excellent products. When applied correctly in controlled conditions, adhesive bonds can last decades. Think of insulated glass units. 2 panes of glass bonded together with structural sealant. They do not fail. They are assembled in factories where temperature, humidity, and application thickness are precisely controlled. The problem with Brickslips is that the bonding happens on site. If the adhesive is applied in cold or humid weather, or if the substrate is not properly prepared, or if the open time is exceeded, the bond will never reach its design strength. And on the real construction site, under real program pressure, not every single slip gets the perfect condition it needs. And that is very difficult to police. I'm not saying all adhesive systems will fail, but when they do, there is no secondary retention. And that is the risk you need to understand before you choose one. A standard brick slip weighs around 700 grams. Falling from the 6th floor, it hits the ground at roughly 70 kilometers per hour, which is more than enough to shatter a windscreen or cause a serious head injury. Mechanical systems do not have this problem. Each slip is physically fixed to horizontal rail. The rail is shaped so that it engages with grooves in the back of the slip or holds the slip by purpose-made mechanical features. The slip cannot fall off unless the rail itself is destroyed. And the rails are made from stainless steel or aluminum, designed to last the full service life of the building. The rails are fixed back to the wall through brackets and vertical carrier rails that form the cladding subframe. Each bracket is engineered for wind load, dead load, and building movement. Traditional brickwork is also mechanically connected to the structure through wall ties spaced at maximum of 900 mm horizontally and 450 mm vertically, and steel shelf angles at each floor level or at every second floor level. It is a proven system. Both systems have something in common. You can trace the load path from the brick all the way back to the structure. But traditional masonry has one hidden problem. Over my career, I have inspected my fair share of cavity walls. Want to know how many of them had a perfectly clean cavity? Almost none. When the bricks are laid without sufficient care, mortar inevitably falls into the cavity. Pieces hang on the wall ties, other land on the cavity trays. Sometimes entire half of bricks drop into the gap and get left there. And that is before you count the general construction debris, bits of packaging, offcuts of membrane, and everything else. Now, I've seen packs of cigarettes, cans of soda, gloves, and protective goggles in these cavities. This is not bad workmanship by one particular crew. This is the reality of how brickwork gets built on real sites under real program pressures with real bricklayers. Every piece of debris sitting on the cavity tray is a potential moisture trap. The cavity is supposed to protect the building from water penetration, yet it is often compromised before construction is even complete. Ventilated rain screen cladding systems also have a cavity behind the cladding, but it works differently. In the traditional masonry, the cavity is an enclosed drain space between brick leaf and the inner leaf. It's only drained at the bottom through the weep holes. In the ventilated rain screen system, the cavity is a ventilated airspace open at the top and bottom for airflow. Both serve to manage water, but ventilated rain screen brick slips, there is no wet mortar during installation. It is a dry fixed process, so there are no mortar droppings falling into the cavity in the first place. Now let's talk about maintenance. What happens when the facade needs repair? This is something almost nobody thinks about until it's too late. Think about what happens with traditional brickwork. If a section gets damaged, somebody has to come out, cut it into the wall, carefully remove the old bricks one by one, and then rebuild the area. On top of that, they need to find mortar that matches the original color and somehow replicate years of natural weathering on the surrounding surface. However, the patch will always be visible, and there is nothing you can do about that, especially on a building that is more than 10 years old. Now compare that with mechanical brick slips. If a slip gets damaged, the repair is straightforward. The installer scrapes out the pointing around the damaged unit, disengages the clip, slides the new slip, and pointing it back up. The whole process takes minutes rather than hours. You are replacing like for like, the same product, the same color, the same texture. The new slips will look slightly different until it weathers in, but you will never have the color matches you get when you're trying to patch traditional brickwork. And the whole process is significantly faster and easier. Over a 60-year building life, any facade will need repairs at some point. Vehicles impact, storm damage, vandalism, window replacement. It is inevitable. This is only a 10-minute video and we have barely scratched the surface. If you want to have full picture, fire safety for every system, thermal bridging analysis, specific product comparison, we have full course on these topics and run a dedicated technical webinar. We go deep into every major system type with dozens of 3D details, animations, thermal performance analysis and embodied carbon comparison, plus an honest professional opinion on what works and what does not. The link is in description. There's one more thing you absolutely need to know. The regulatory landscape has transformed. In the UK, for residential buildings above certain height, every material in the external wall must achieve A1 or A2S1D0. In simple terms, materials that do not burn, produce toxic smoke, nor flaming droplets. Other countries have similar height-based fire restrictions in place, so wherever you are building, this is something you need to check early. And this requirement immediately eliminates entire product categories. Certain insulated panels, adhesives, certain backing boards, they are all gone from high-rise specifications. The good news is that clay brick does not burn, and mechanical brick slip systems made from non-combustible components do not burn either, so they pass the fire test at any height. So which facade type is the best? If you have unlimited budget, plenty of time and access to skilled tradespeople, then traditional masonry remains an excellent choice. It does not burn, it is century proven, and it looks beautiful when done well. If you need speed, a lighter structure, better quality control and fire rating that works at any height, then mechanical brick slips are worth a serious look. This is the fastest growing sector in the brick facade market. If your building is below 11 meters and costs is the driving factor, certain adhesive systems may work, but make sure you understand the retention method, check the track record of the specific product, and think carefully about what is below, at the ground level. The answer is not the appearance. From the street, all three facades will look identical, and that is the whole point. The real answer lies in understanding your specific project, its site constraints, the available labor, the program pressure, and your appetite for risk. And that is the real skill of facade engineering. It's not about choosing the abstract best system because there is no such thing. There's only the right system for a given project. If you want to go deeper into the technical details, the product comparisons, the fire testing, and the thermal performance data, we have built an entire course around this subject, packed with interactive 3D details, multiple choice questions, lectures, and live webinar, which we encourage you to attend. The link is below, and I will see you there. Bye!